Welcome to the notes for 10.1. We are going to go back to a topic that you know and love from your days in Algebra 1, but we're going to put a little polar twist on it. I know you're excited. But this is section 10.1. We're going to go back and talk about linear functions, but we're going to talk about them in relation to inclination. So inclination is a measure, it's an angular measure of a linear function that we measure counterclockwise from the x-axis to the line. So for example, if you had a linear function with a positive slope, let's think about just what that would look like, right? Imagine that you have a linear function and it has a positive slope, so it's going uphill. It could go through the origin, it could go anywhere. The only thing I want to talk about is that it has a positive slope. So I'll just sketch one in. Doesn't really matter where you put it or how you drew it. We are going to measure the angle between that x-intercept and the x-axis, and we'll talk about theta being equal to that angle. If you have a positive slope, then you are guaranteed to have an angle that is between 0 and pi over 2. We'll come back and we'll talk about why there's not equal signs over here. We'll talk about those special cases. What would happen if you had a negative slope? What would be true about that angular measure? Well, negative just means you're going downhill. Doesn't matter which slope you draw or which line you draw. If I were to measure the angle between the positive x-axis, so I'm on that right-hand side, and that linear function, I would get an angle measure that measured between pi over 2 and pi. And this, I should label it, is my example of a negative slope. And so if you look at the top, we are defining inclination, this idea of using an angle measure to define a linear function. We are using only values that are between 0 and pi. Let's get rid of that for a second. We're going to define inclination to be between 0 and pi. So I've taken care of 99.9% of cases, but notice I have left off a 0 degree angle. What would that look like? If you had a 0 degree angle, now this one you have to imagine that you are moving it, but any horizontal line, if you transpose that and translated it back on top of the x-axis, we would talk about a horizontal line having a theta equal to 0. So if you had an equation like y equals some constant, then you would talk about having an inclination of 0. That would translate as a horizontal line. And I'm going to be just a tad short on space, so we'll squeeze it in here though, make a really small axis. If you had a vertical line, we'll put it right on the edge here, then what would be true about your angle? Your theta would be equal to pi over 2. If you made a right angle with your x-axis, then you would be talking about a vertical line. We're back in the rectangular plane today. We're not graphing in polar necessarily, but we are relating back to angles. So these are sort of your 4 options. Again, we define our inclination as the angle between the positive x-axis and your linear function. How could we go about finding this? How could we find the inclination? Well, let's use our picture from the positive slope. It's the easiest one to sort of work with. All we would need would be 2 points on our linear function, and we could measure the change in x, we could measure the change in y, and that would be enough to use right triangle trig to come up with our inclination measure. So kind of like we've done in polar coordinates with theta, finding those direction angles to plot points, kind of like we did with vectors, we can use the formula m, slope, is equal to the tangent of theta, or we can talk about our slope being equal to the tangent inverse oops, sorry, I copied that down wrong. If I wanted to solve for my inclination, right, my theta would be equal to the tangent inverse of m, right? Because remember, what is slope? It's your change in y over your change in x. So you've got that opposite leg to your adjacent leg, and we are now defining our slope in relation to the angle between the positive x-axis and that linear function. One quick note, right? Our theta, because of the way we've defined inclination above, theta is only between 0 and pi. We wouldn't be able to tell the difference between a pi and a 0, right? It would just be another horizontal line. So we are going to go with 0 for our solution. So we've got a couple questions about taking our rectangular equation and sort of polarizing it, talking about what would be the inclination, what would be the angle that would define this. So the first thing to do is just to think about our formula, right? If I want to find the inclination, then I'm looking at this formula right here, but I would need to know the slope. This one, it's there, I just need to know where to look for it. I'm going to set this in y equals mx plus b form. So I would subtract the negative root 3x, I would subtract the 3, and then I would need to divide. So negative root 3 over negative 3, make that positive, and negative 3 over negative 3, so plus negative 3 over negative 3. The equation for my line would be root 3 over 3x plus 1. Don't really need the plus 1, I need the slope. That would mean that theta is equal to the tangent inverse of root 3 over 3. Now this one you do not need a calculator for. Right? What angle has a tangent of root 3 over 3? That is the shorter of the two. Theta is pi over 6. And that would be my solution. Here's another one, just as an aside. If you want, in fact, go ahead and hit pause, work it out, and then you can sort of fast forward through and check my answer. I won't wait, I'll keep going here, but if you wanted, you could do it on your own. So let's try this one. Again, same steps. I would need to solve this equation just to see its slope. So really at that point, I could look at it and go, oh yeah, my slope is going to be negative 2/3. That means that theta would be the tangent inverse of negative 2/3. Now I picked this one on purpose because if you go ahead and put it in your calculator, we're going to work in radians, you will get negative 0.588. And what's happening is that your calculator is programmed with that tangent inverse rule from chapter 4, true inverse functions. Tangent is only defined between negative pi over 2 and positive pi over 2. So that negative 0.588 is telling me, right, this piece right here. The problem is in how inclination is defined. According to the definition, inclination only exists between 0 and pi, so I cannot give a negative answer, it's less than 0. How would I get sort of the same angle? Well, I need to rotate it back so that I can think about like negative r's and landing on here, right? The angle that I'm really after then would be to take that value and add pi. So I'm going to go ahead and add pi to that solution, and that gives me theta equals 2.554. You cannot give the negative solution or you would be marked off because of the definition of inclination. On the back, we have a couple of applications for this. So imagine that we are working with these linear functions. We want to talk about the angle between any two lines. There's a formula for that. It's the tangent of theta is equal to, we've got the absolute value of m2 minus m1 over 1 plus m1 times m2. And imagine you have two linear functions. There's actually two angles here that are going to be given to you. We'll just go with whichever one pops out of our formula. It's going to be positive, right? Because the absolute value is going to force this value to be positive. And then, like we said, tangent inverse will pop you into quadrants 1 or 4. Given that I'm guaranteed a positive, that's going to put me in quadrant 1, which is fine. It just means that I would always be solving for the smaller angle here. If you, for some reason, needed to know it, maybe you're doing a story problem and actually the bigger one, you would have to adjust. But if you're just talking about in the context of angle between, you can just report out that smaller positive value. So let's do an example. M1 and M2 are referring to the slopes of the lines. So if line 1 is this equation, remember we'd have to actually solve for this one. That would make y equals negative 2x plus 4, so my slope is negative 2. And on this one, right, maybe you want to imagine moving the y over to make it positive. I'd get x minus 2. That means that M1 is negative 2 and M2 is positive 1. So those are my two slopes, and I'm going to go ahead and plug into my formula. So tangent of theta would be equal to the difference between them, so 1 minus a negative 2, and then I would have 1 plus, and then I'm going to multiply them together. So negative 2. That's going to give me tangent of theta is equal to the absolute value of 3 over negative 1, and I will ask my calculator, theta equals tangent inverse of, it would be negative 3, but it's absolute value, so positive 3, and you end up getting 1.249, and that's in radians. So go ahead and you can try those on the homework. There's one more formula to know, the distance between a point and a line. So imagine that you have a linear function and a point somewhere out in space. When we talk about distance in geometry or here in pre-calc, anytime really in math, typically you're talking about the shortest distance. So the d that you're measuring would be the perpendicular distance from the point to the line. The formula for that is d equals, and we would take the absolute value of a times x1 plus b times y1 plus c, all that in absolute values, over the square root of a squared plus b squared. Now, we want to make sure that we're paying attention to what's what. Notice that they have written their linear function in standard form. We don't do this a lot because it doesn't give us a lot of information, but the a, the b, the c, those would be written in standard form. A is the coefficient on x, b is the coefficient on y, c is the constant, and it has to be on this side. And then x1, y1 that they're talking about is the point off in space. So x1, comma, y1. So do be careful. You have to have it written in that form. So here's an example of just trying that out, right? 0, 2, that would be my x1, 0, y1 is my 2. In this particular formula, a is 4, b is 3. It's already written in that standard form. There is no plus c. That implies that c is 0. So the distance would be equal to, I'll take a times x1, so 4 times 0. I'm going to add b times y1. And then I'll add c, which was 0. All divided by the square root of, 4 squared plus 3 squared. I'm going to get 0 and 0, so that's going to be 6 over square root of, what do we have, 16 and 9, so 25, or 6/5. So go ahead and try those out in the homework too. This section's really nice. It's basically 3 formulas. You've got your inclination formula, your angle between the two lines, and your distance from the point to the line. You've got an assignment here to work on. You can use the rest of the hour to get started or finished even on that. Thanks for watching.